Hello guys, back for another lesson. Like yesterday, this topic will be a review of something from Algebra 2, so you already should be familiar with it. Of course, it's okay to forget things over the summer, but as far as relearning it goes, it should be a little bit easier than it was the first time around. So, we are reviewing the quadratic formula and the discriminant. Both of these things relate to a quadratic equation. Quadratic equation, it's an equation that's usually set equal to 0, or you can make it equal to 0, and it has a second degree, or it consists of a second degree polynomial. So normally there's 3 terms. There could be fewer than 3 terms, but 3 is pretty normal. Second degree polynomial. Now, what's important to know about this is when you're using these formulas, you need the number in front of x squared, number in front of, that's called the coefficient of x, and then the last number, which is not technically a coefficient, it's called a constant. But every problem is basically going to have an a, b, and a c in it, and you need to be able to pick those out in order to work it through. So here's our goals. We're going to use the quadratic formula to find an approximate and exact solutions to quadratic equations. And I'm going to write the formula down. And then we're going to use this thing called the discriminant to find the number and types of solutions to a quadratic equation without actually solving it. There's a formula for that, and when you use that formula, there are 4 possible outcomes. So what I'm going to do is I'm going to just focus on the quadratic formula first, go through examples, then come up here and talk about the discriminant. The quadratic formula, as you may remember, is this. X equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And when you work this out, you're going to do an addition step, and then you're going to go back and redo it with a subtraction step. So plus minus means 2 different things. You're going to add once and then subtract once so that you get 2 answers. Now, it is possible to get 1 answer. We'll talk about that when it comes up. All right, so it's just a use of this formula, and you should certainly remember that from Algebra 2. So, as normal, I am going to go ahead and do the even problems. Your homework will be the odd problems. No special instructions here. You'll see I wrote in some instructions lower, but number 2, we should be able to solve straight away, no problem. The first thing you want to do is identify a, b, and c. In this problem, a is the number in front of n squared. You don't see a number there. That's that invisible 1. So a is a 1 in this problem. B is negative 3. Oops, make that look more like a 3. That's this number. And then C is negative 28. So the solution to this quadratic equation, x equals negative 3, which is a silly thing to write down. I know. The formula has a negative sign in it. Here, what am I doing? The formula, as you can see, has a negative sign in it right there. And the 3 is already negative. So I write negative. I bet you already know that 2 negatives make a positive. And I'll do it that way in the future. But for now, negative. You know what? Let me pause for a second and just write the formula here real quick so I don't have to scroll up and down all the time. All right, there it is. Okay, so negative 3 plus or minus the square root of negative 3 squared. Notice I put that in parentheses. When you square a negative number, you always put it in parentheses. Minus 4 times a, which is 1, times c, which is negative 28. Also put that in parentheses. Just when you multiply by a negative, sometimes it's a little more clear if you put it in parentheses. All over 2 times a. So this is the equation which we must solve. Again, a double negative, pretty easy. That's positive 3. Bring down the plus or minus, square root. Negative 3 squared, that's 9. Let's see, minus 4 times 1 times 28. I need to work this out. And you know what I'm going to do? I'm going to pull up a calculator just to make life a little simpler. Maybe you should expect me to be able to do this in my head, and maybe you're right, but I am going to use a calculator. Negative 4 times 1 times negative 28. That's a positive 112. So I'm going to write down plus 112. So we did have a negative here, a negative here. When you multiply them, they turn into plus. And that's all over 2 times 1. 2 times 1 is 2. Now I can still simplify that. 3 plus or minus the square root. I don't need a calculator for that. 9 plus 112 is 121, all over 2. Just kind of going through order of operations right now. Next thing I'm going to do is the square root of 121, which I know is 11, but there, now you see it, 11 over 2. And then here I split into 2 branches. I'm going to do 3 plus 11 over 2 and 3 minus 11 over 2. So this is where that plus minus becomes 2 math operations, and it's going to lead us to 2 answers. 3 plus 11 is 14 halves. 14 halves is 7. And 3 minus 11 is negative 8 halves. Negative 8 divided by 2 is negative 4. And those are the 2 answers, 7 and negative 4. All right, let me scroll down to number 2. And there are the answers, 7 and negative 4. This is written with these funny brackets, and the comma there is called set notation. So you'll see answers written like that fairly often. I just circle the answers, no big deal. Now, when you do this whole quadratic formula and you come up with whole numbers or integers as solutions, what that means is, if you care, this is a little extra. You can kind of tune me out right now if you don't want to learn extra stuff. But I'm going to do it anyway. What that means is you could have just factored this one and solved it that way. So you put an n and an n. So this is like what we did yesterday. 2 numbers that multiply to 28 and add up to negative 3. I'm sorry, negative 28, negative 3. That's going to be negative 7 times positive 4. And then when you set each one of these equal to 0, you get n equals 7. And then here subtract the 4 over n equals negative 4. Same 2 answers. This one could have been done without the quadratic formula, just kind of illustrating the point here. For this assignment, that's the way we want to do it, though. Use the quadratic formula. Now, for numbers 3 and 4, round to the nearest thousandths place. This one is not factorable. I cannot come up with 2 numbers that are going to multiply to negative 15 and add up to 9. Think through all the combinations. 1 times 15, 3 times 5. There isn't much else. You could try like 2.5 times 7, right? Or no, 2 times 7.5. What am I doing? Duh. 2 times 7.5. You could get into decimals and things, but they're not going to multiply to 15 and add up to 9. It's just not going to happen. So here we have to do the quadratic formula. So in this problem, what's A, what's B, what's C? A is once again 1, B is negative 9, C is negative 15. So here, here, and here. Let's do the formula. X equals negative 9, so that's a positive 9, plus or minus the square root of negative 9 squared minus 4 times 1 times negative 15 all over 2 times 1. Well, I'm going to show you something. I could have done on the last problem, but I was a little stingy. But here, I'm going to type this into my calculator instead of working it out step by step by step. And as far as I'm concerned, you do have this as an option. So if you're using Desmos, you need to hit the divide button first, and that sort of sets up a fraction. On the top, I'm going to go 9. Now, I don't have a plus minus button. I'm just going to do plus square root, parenthesis, negative 9, close parenthesis, squared. You got to get these parentheses right. If you type things in the wrong order, it's going to give you a wrong answer. Here you don't really need the parenthesis, but on the power you do. So I typed in everything as it appears there, and then on the bottom, 2 times 1. And this gives me x equals 10 point, and then there's a bunch of decimals. Now the directions say to the nearest thousandths place. In decimals, that means 3 places. It goes tenths, here, tenths, hundredths, thousandths. So 10.437, you can see on that calculator over there. So that's the plus answer. What about the minus answer? Well, I could go back and retype this whole thing, or I can just tap my screen right there. You see where the cursor is on the calculator? Backspace, and then hit the minus button, and it gives me the second answer without having to type all this in. x equals negative 1.437. So those are my answers. Let me scroll down to number 4 and see if that's indeed correct, or did I mess up? Oh, I was looking at number 3. I thought I messed up. Nope. There it is. Both answers correct. So the calculator, could I have done the calculator on number 2? I sure could have. Like it said, I was a little stingy up here. I showed every single step to, I guess, bore you. I don't know. I'm not a nice person. But yeah, I over-explained number 2. Number 4, as long as you figure out what A, B, and C are, plug them into the formula correctly. That means parentheses around negative numbers, things like that. And then type it into the calculator. Once with a plus sign, once with a minus sign, you can get your answers. Now, that's good for 1, 2, 3, and 4, or for your homework as far as that's concerned, 1 and 3. We get down to 5 through 8, we now need to give exact answers, and the calculator becomes less helpful in this situation. The process starts out exactly the same. So in this problem, A is 2, B is what, negative 6, C is negative 23. My formula, x equals negative 6, so that's going to be positive 6, plus or minus square root negative 6 squared minus 4 times 2 times negative 23. Oh, I think I'm going to need the calculator. All over 2 times 2. So I'm going to simplify this. 6 is going to stay a 6. Tell you what, let me pull the calculator back up. Everything that's under the parentheses here, I can type into the calculator, so I'm going to do that. I'm not going to type in the parentheses, though. And I have reasons. Just trust me for now. So I'm going to type in parenthesis negative 6 parenthesis squared minus 4 times 2 times negative 23, and that's 220 all over 2 times 2, which is 4. I don't need a calculator for that. Now, why did I not use the square root? Well, if I did square root, negative 6 squared minus 4 times 2 times negative 23, that gives me a decimal answer. The decimal answer was fine up here because it said to the nearest 10,000ths place. But here we need to give exact answers. A decimal like this at some point has to be rounded off. What you see on the calculator screen over there, that 2 at the end is a rounded 2. It's not necessarily an exact answer. The decimal goes on infinitely. So how do we take this and make an exact answer out of it? Well, sometimes what you see right here, that is your answer. That's it, and you are done. However, on this particular problem, even though the square root of 220, as we saw in the calculator, is an irrational number, it's one of those decimals that goes on forever, it still can be simplified. And this is an Algebra 2 thing you may or may not have loved way back in the day. But I'm going to look at 220, or the square root of 220, and see how I can simplify this. And 220 works out to be 2 times 110, and 10 works out to be 2 times 55, and 55 is 5 times 11. And what we have is a pair of 2's. So what we're looking at here, square root of 220, it's really square root of 2 squared times 5 times 11. Well, square roots and squares are opposites. They cancel each other out. So if this square root cancels out this square, that means the 2 itself, the base, can be simplified out of the square root, or the radical. Now 5 does not have a square, 11 does not have a square, so there's nothing for that to cancel out. That stays under the radical. And of course 5 times 11 is 55. So the square root of 220 simplifies to equal 2 radical 55. That means this answer can be expressed 6 plus or minus 2 radical 55 over 4. So hopefully that's a process you remember seeing at some point. But I'll tell you, if I circle this and then go to check my answer, it's still not going to be right. Let me just show you. Let me go down to number 6, wherever it is, right here. And it's 3 plus or minus radical 55 over 2. 3 plus or minus radical 55 over 2. So it's not a 6, there's not a 2 here, there's not a 4 there. What's up with that? Well, you know something about fractions, I'm sure. You know, if you had something like, let me make up, like 12/16. There's this thing called reducing, and you can divide both of these by 4 and you get 3/4, right? You can reduce fractions. That's what's going on in this problem. It's just a little more complicated. This fraction has 3 terms. 6 is a term, 2 radical 55 is a term, and then on the bottom 4 is a term. If you can reduce the same value out of each term, you're supposed to do it. Now, the radical 55 doesn't really count. You can only reduce radicals with other radicals, or in this case, non-radicals with other non-radicals. So if you look at the 6, the 2, and the 4, what number can you divide out of each of those? Do you know it? They're all even numbers, so you can divide a 2 out of each one of those. Divide 6 by 2, you get 3. Divide 2 by 2, you get 1. Divide 4 by 2, you get 2. So that's 3 plus or minus 1 radical 55, which you don't need to write the 1 down, over 2. And that is our answer. Or when we checked it down below, it was written like this, with a comma. And then, of course, those funny brackets. If you just want to circle that, call that your answer, I'm happy with that. If you want to split it up into 2 answers, that's fine as well. But now, this is considered an exact answer because we didn't have to round off any values to solve it. The 3, the 55, the 2, those are exact values. Nothing has been altered or changed. Like up here, we rounded to the 3rd decimal place. Okay. Let's look at number 8. 8 is kind of repetitious of number 7, a lot of the same steps. So in this problem, A is 7, B is -6, C is 3. So if we use the quadratic formula, -6 plus or minus the square root, -6 squared minus 4 times 3 times 7, all divided by 2a, that's 2 times 7. So once again, I'm going to use the calculator for -6 squared minus 4 times 3 times 7. That gives me -48. And then 2 times 4, of course, is 14. Notice I did not use the square root on the calculator. If I had done that, square root, parenthesis, -6 squared minus 4 times 3 times 7. That says undefined, and that doesn't do us any good at all. So I did that part of the math without the square root button right there and got -48. So now we need to simplify this. Well, can you recall from Algebra 2 something special about square rooting a negative number? If you know what I'm about to say, make a comment somewhere like, I knew you were going to say that on number 8. I knew it was coming. All right, I'm going to scroll down to the answer for number 8. And there it is. 3 plus 2i radical 3 over 7. 3 minus 2i radical 3 over 7. What is I? I is called the imaginary number, and it comes from the fact that it's impossible to square root negative numbers. What is the square root of negative, I don't know, let's come up with some random, 16. Well, what's the square root of positive 16? That's 4. The square root of negative 16 can't be 4, because 4 times 4 is positive 16. It can't be -4, because -4 times -4 is still positive 16. It's not -16. And it can't be -4 and +4 because square root means the same number times itself, not 2 different numbers. So for a long time we said the square root of a negative number is undefined, like the calculator said, but then some genius sometime, invented something called the imaginary number. So really you look at this as the square root of 16, which is something you can do, times the square root of -1, which is impossible. The square root of 16 is 4. The square root of -1, since it's impossible, we call that the imaginary number, as though it doesn't really exist. And that's what the invention of the imaginary number. So when you square root a negative number, like in number 8, we're going to end up with an imaginary answer. So it's going to be 6 plus or minus, and we know it's going to have an I in it. So anytime from this point forward, when you square root a negative, it's either going to be a no solution or it's going to be an imaginary solution. All we got to do now is simplify the square root of 48, a lot like we did up here with 220. So 48 being an even number, that's 2 times 24. 24 is still an even number, that's 2 times 12. And that's 2 times 6, and that's 2 times 3. So it looks like we got a pair of 2's here. Ooh, let me make that more easy to read. A pair of 2's is 2 squared. Another pair of 2's is another 2 squared. And then we have that 3 there. So when we square this, the square root and the square cancels, I can pull out a 2. The square root and the other square cancels, I can pull out another 2. The square root has nothing to cancel with on that 3, so that's going to remain under the square root bar. And of course, what you're looking at right here is 2 times 2. We can go ahead and call that 4 radical 3. So what we get is the fact that there was a negative here creates this I. We factored out or simplified out this 4, so I'm going to go ahead and put a 4 in front of the I. This radical 3, square root of 3, is going to stay put. We cannot simplify that at all. And now we've got a fraction like the last one we can reduce. 6, 4, and 14. What can you divide out of all three of those numbers? And the answer is 2. 6 divided by 2 is 3. 4 divided by 2 is 2. 14 divided by 2 is 7. So we get, for a final answer, 3 plus 2i radical 3 over 7, and then 3 minus 2i radical 3 over 7. Put it in the little brackets there, whatever. That is the answer, which I just showed you, but I'm going to double check because sometimes I get paranoid. Yep, there they are. So anytime you do a quadratic, if you need to square root a negative number, you write the letter I down in there, and that sort of takes care of that negative sign. Okay, number 3 should work a lot like number 6. Number 7 should work a lot like number 8. I believe I did set them up that way. So yeah, it's not just some random mixture of problems. They're very systematic the way they go. So if you get stuck on number 5, follow the steps on number 6. If you get stuck on number 7, follow the steps on number 8. That moves us to the next section, which is find the discriminant of each quadratic equation, then state the number of solutions. So let me come back up here to the notes section and give you the formula for the discriminant. Now this work is easier than what we just did. If you're feeling discouraged because we did a lot of work right now and there's even more coming, at least know this is easier. The discriminant formula is b squared minus 4ac. So what it is, it's really just a section right there of the original quadratic formula. It does not include the square root. So that's it. That's the formula. And when you do this formula, you can use a calculator. That keeps it pretty simple. There are 4 possible outcomes. So one outcome, b squared minus 4ac. You do this in a calculator or do it in your head, whatever, and you get a number that is greater than 0. Greater than 0 is what we call a positive number. I bet you knew that. That means there are 2 real solutions. I'm going to abbreviate solutions. You could have b squared minus 4ac equal 0. If the discriminant, that formula, works out to equal 0, that means there is 1 real solution. One solution didn't happen in any of my examples, but I want you to think of it this way. If what I have highlighted in yellow there is a 0, then you take the square root of 0, it's still 0. What's going to happen when you add or subtract 0? Pick any number in your head. Now add it to 0 and then subtract it by 0. You get the same answer twice. The same answer twice is just like saying there's only one answer. So for the scenario here too, if b squared minus 4ac equals 0, there is 1 real solution. The third outcome is that the discriminant, b squared minus 4ac, do it on the calculator, is less than 0. Well, less than 0 is what we call a negative number. And what did we just say about square rooting a negative number? It can't be done. So we invented a new system. We didn't, but someone did. A new system called imaginary numbers. So there are two imaginary solutions. And 4 outcomes? How did I put 4 outcomes? There's only 3 outcomes. That's all there is. Wow, all right. Losing my mind, but that gives you a lot of confidence in your math teacher. So good news, guys. There's only 3 outcomes. 2 real solutions, 1 real solution, or 2 imaginary solutions. That's what we're looking at, and that's what we need to do for these last few problems. So, number 10. Oops. Find the discriminant, then state the number and type of solutions. First of all, A is 6, B is 10, C is -4. So the discriminant is 6 squared minus 4. I'm sorry, that was dumb. B squared minus 4AC. So that's 10 squared minus 4 times 6 times -4. And I'm just going to use a calculator. 10 squared minus 4 times 6 times -4. That works out to be 196. So the discriminant is 196. So find the discriminant. Done. We did it. Now state the number and type of solutions. Well, what scenario is 196? Is it greater than 0, equal to 0, or less than 0? 196 is greater than 0. So 2 real solutions is what we need to write next. So 196 is the discriminant, comma, 2 real solutions. And let me check number 10. 196, 2 real solutions. Let's look at number 12. A is 5, B is 1, C is 2. 1 squared minus 4 times 5 times 2. 1 squared times 4 times 5 times 2. Oops, no, minus. Wow, that was about to be a mistake. I get -39. -39 is less than 0. What does that mean? Less than 0, 2 imaginary solutions. So -39 is the discriminant, and that means there are 2 imaginary solutions. That should be the answer to number 12. Let's check. -39, 2 imaginary solutions. Got it. And number 14. A is -8, B is also -8, C is -2. So B squared minus 4AC, that's -8 squared minus 4 times -8 times -2. Let me do this on a calculator. -8 squared minus 4 times -8 times -2, 0. Let's go back up to the notes. What does 0 mean in terms of discriminant? That's the middle one. That means 1 real solution. 0 means 1 real solution. So a discriminant of 0, where am I? Good grief. 0, comma, 1 real solution. Circle it and check my answer. There it is. Okay, now I am not going to say that number 9 is just like number 10, and 11 is just like 12, and 13 is just like 14. It does not work that way. I've mixed them up. So you will have one of each answer, but it's not going to be an exact, number 9 will be 2 real solutions just like number 10 was. It's not going to work that way. The discriminant is pretty easy once you get it done. Once you get it down, the quadratic formula isn't difficult, but there are steps that might cause you trouble possibly if you don't remember imaginary numbers, if this whole process here gives you issues. Those are the things you're going to want to reach out and contact me if you need help. Otherwise, do your best to do this. Show your work where it makes sense. Check your answers before you submit this. Let me know through email or comments if you do have questions.